take a screenshot or go to this link first. So we'll be addressing all the live questions here. And also how we'll be structuring this workshop, right, is throughout the workshop, we'll have, we'll intermittently break you guys into breakout rooms where you guys will have like what you have just learned to the problem sets. So Noel, you can start.
Okay, thanks, Jared. Hey guys, I'm Noel. I'm the Tech Associate in DSC. I'm from Year 2 Computing. So today's workshop is going to be about Python and data science. So if you're, like Jared said, receiving live questions in this link, Padlet, you can also ask on Microsoft Teams or on the Zoom chat. So a bit about DSC NUS. So DSC was started at the beginning of the last academic year. Over the course of the past year, we have increased the number of members in our club a lot. So DSC is like a student-run club, which is found all over the world across universities. It's not affiliated to Google. Google is the one who gives like a inspiration for students to start this club. So there are over 750 clubs across US, Canada, Europe, Africa, and Asia. So what do we do in DSC? So DSC comprises of members who are passionate about technology. So we aim to use technology to make a difference in society. So in DSC NUS, our motto is Tech for Good. So we are passionate about using tech to further social causes. So the main activities we organize every year include our annual hackathon called Hack for Good, where we provide a platform for tech enthusiasts to solve social issues. The next one is we organize workshops like this one. So this year, for this semester, we have 3 workshops, including this one. So the first one is data science and Python. Second one and third one are for machine learning. And thirdly, we provide industry talks. So we bring in people from different industries and different career paths to give you an idea of the different roles out there and how you can work towards entering the industry. You can follow us on our social media platforms on Telegram, LinkedIn, and Instagram. I'll give you a moment to scan the QR code if you need to. It's also there on your slide, so you can always go back and check. Okay, and this is our team. So Jared is the tech lead. He's from Computing Year 2. Then we have Utkarsh from Science Year 1, Sebastian and Tim from Computing Year 1, and Justin from Computing Year 1. Myself, Noel, and Kang Liang from Computing Year 2. Then Xiao Yi from Computing Year 3, and Luke from Business Year 3. So if you have any doubts, you can ask any of us to the Zoom chat. I think, yeah. Hey guys, so can you switch on your video if possible? All the tech team members. Jared. Yeah, so if you see any of us on video, it's one of the tech team members. Okay, so let's get started then. So today's topic is Introduction to Python and Data Science. So you can skip to any of the topics here by clicking the link. So today's learning objectives are to understand the fundamentals of the Python programming language. So understand the syntax and the basics of the language and the core concepts of operators, conditionals, variables, loops, and functions. So after we give you a basic idea of Python, we'll go on to the basics of data science. So we'll show you how to use important libraries like NumPy, Pandas, and Matplotlib. So you can get a general idea of what data science is and how we use Python to, do data science. And we can give you a small intro to the real world applications of data science. So we'll be analyzing a data set and making some visualizations using Python. So why Python? So the main reason we chose Python is because it's very easy to learn. For beginners, Python is one of the easiest languages to pick up because the syntax is very similar to English. Another reason is that it has a lot of great libraries, right? So libraries like a collection of pre-written code. So if, say, someone else has already written a lot of code and done a lot of programming, then he basically uploads that code to the internet and it's free for all to use. So that kind of code is called open source code. So Python has a lot of open source libraries which are free for people to use. And these libraries make it much easier for us to just start a new project. So instead of starting from scratch, we can just, we have a head start by using other people's code to help us bootstrap our projects. And because of these great libraries, we come to the third point, that is, it's very widely used for data science and machine learning. So knowing Python can be a very useful skill for internships and for the industry in general. Okay, so today's course workshop will be running everything on Google Colab. Colab is an online interactive environment on the browser where you can run Python code. So it's provided by Google. It's mainly used for machine learning and data science. And the thing is that the code you run on Colab is actually run on the browser. You don't have to use your computer at all, meaning you don't actually have to use it won't affect the computer's memory or speed, because the backend is run on Google's computers. All you're doing is using the web browser. And Colab also allows you to run code from anywhere in the world, because all you need is a Google account and internet connection. So all the code you write is saved on your Google Drive, so you can access it from anywhere, which makes it very convenient for running machine learning projects. Okay, so I'll give you a basic intro to Colab. You can switch over to Colab. So this is the Colab environment. Basically, you have this thing called a cell, right? You can write Python code here. So you write your code, and then you basically see this play button here. You can press the play button to run the code. You can also press Control Enter to run the code. So whatever code is in this cell will be executed. It'll take a while. So you can see this right button here saying connected. So once connected, it'll run the code. And then whatever output you have from the code will be printed out into the console below it, over here, in the box below it. So this is a cell. And then you can add on more cells at the bottom. So you can write code and then you can execute it from different cells. So the main advantage of this method is that if you have a big program, you can write like chunks of code in each cell. So you can basically run each cell one by one, and you can easily debug it. So you can write some more code here and run it. Okay, so for today's workshop, we emailed you a file for Colab file. So the way you probably have it in your Google Drive. So this is the file. It's called Introduction to Python. It's a .ipyb file. So to get started, you have to actually upload this file onto Colab. So I'll show you how. Just download the file first. And then after you download, go to your Colab notebook. And then go to File, and then Open Notebook. Sorry, Upload Notebook. Then you choose your file from your directory. So download, and you choose the file. So it'll upload the file into Colab, and then you can run the code there. Yeah. So once you see this page, just press connect on the top right corner. So it'll connect to an instance of Colab, so your code can be run. Okay, so one more thing I want to mention before we start is that when you write code, you can also comment it out. So when you comment out code, it means that it's only for your reference. It's not actually executed. So the shortcut to do this is Control/, right? So if I just go to a specific line and press Control/, it will automatically comment out the code or uncomment it. So I'll be using that quite often, and that's a shortcut for you to be familiar. Okay, so let's get started then. Yeah, so the code is typed in the shell. In the cell, you can press Shift-Enter to run the code. And one more thing to note is that the code is run in order, which means that sometimes if you run code in our Python Colab that we shared, if you forget to run the cell above, then sometimes the cell below won't work. So you have to actually execute the cells in order to avoid any errors. Because sometimes we declare a variable on top, and then that declaration is dependent for the bottom. The bottom depends on the top. So basically, try to run your code in order of the cells from top to bottom. Okay, so Python fundamentals. So in Python, we have something called objects. Objects are the fundamental things that Python manipulates, right? So, and each object has a specific data type. What this means is that everything we work with in Python is something called an object. And an object is simply like a number or a word or a Boolean value or a float. So integer is a type of object. So integer numbers include is any integer basically, and a float refers to decimal values. So 3.0, 3.17. That's called a float object. Boolean is any true or false value, and a string object is basically a collection of letters. So a word is a string object. So to find out what type of object specific, like what the type of an object, like they give you 3, and then you want to see what its type is. You can use this type function. So you just enter type and then pass in whatever object you want to find the type of. You get. So type of 3 is integer because it's an integer, and type of 3.0 is a float. Now variables. So when we have objects, we need to keep track of them. So a variable is something that helps you keep track of objects in Python. So in Python, a variable is simply a name or a label that you assign to an object. So whenever you assign a label to an object, you can simply refer to that object by its label in other parts of your code. And an object can have one or more than one labels associated with it. So whenever we code, we try to assign meaningful variable names to our object so we can keep track of it easily and understand our code. So over here, we have a variable called pi, and then we are assigning the value 3 to it, right? So pi is a variable that has the value that contains the object 3. And radius is another variable which has an object 11, integer object. So now how is this useful? Since we are using pi and radius as variables, now if you want to compute something called the area of a circle, let's say, you can simply do area equals pi into radius square. So this is actually more convenient and easier to understand than simply using 3 times 11 square, because you don't know what the 3 is and you don't know what the 11 is. But when you assign that 3 to pi and you assign that 11 to a radius, it's much easier to understand what the code is doing and achieving. Okay, so assignment. So when you assignment in Python works something like this. So let's say I do pi equals 3. So basically I'm taking this variable pi and it points to the object 3. And then I do radius equals 11. Also, I make a variable called radius and point it to the object called 11. So 11 is an object which is stored in memory, and my variable radius points to it. So now I have a third statement called pi equals radius. So now what happens? What is the value of pi? Let's see. So now I change, since pi was initially pointing to 3, right? So now it starts pointing to 11. It starts pointing to the value of radius, right? To 11. Now I declare another variable called area, and it computes pi times radius square, which is 1331. So now the last statement basically reassigns radius to 14. So as you can see, when you do radius equals 14, it doesn't, the thing to note here is that you actually create a new object of new 14, a new integer object with the value 14. The value of 11 doesn't change. This is actually called immutability. So immutability refers to when objects can be changed or cannot be changed. So if an object can be changed, it's called mutable. And if it can't be changed, it's immutable. So in this case, 11 is the integer object, right? And integer objects in Python are immutable, which means that if you reassign radius to another object called 14, then Python creates a new object in memory with the value 14 and then reassigns radius to that. It won't actually change the current 11 to 14. It creates a new 14 in memory and then assigns radius to that. So the key point to take away here is that certain objects are immutable and certain objects are mutable. We'll look more into that later. Okay. So okay, now switch to your collab files. We'll go through variables quickly. I'll give you a demo of the code. Okay, so the common objects, as I mentioned, were integer, float, string, boolean, list, tuple, and dictionary. Okay, I'll wait for 1 minute so that everyone can get to this page first. Yeah, so integers, floats, strings, and booleans are immutable, which means that once you create one of these objects in memory, it won't change. Okay. Then lists are mutable, dictionaries are mutable, and tuples are mutable. We'll cover these later. So for now, yeah, we'll cover variables now. So if anyone at this point doesn't have the Collab notebook or cannot open it yet, please feel free to type it in the chat when one of our TAs will help out. You can also message one of our TAs privately. Okay, so I don't think anyone has a problem. Okay, so I'll continue. So numbers. So integers and floats are numbers, and they're the data types, or they're the objects that represent numbers. So in this code, we have a variable called item price, which is 35.0. It's a float. Then you have tax rate, which is another variable with the value 0.07. So now tax amount is calculated as item price times tax rate. So we can easily calculate the tax amount, which is 2.45. Okay, the next type of variable is string. So a string is a sequence of characters, and strings are immutable in Python. This is very important to note. So the way to declare a string or to initialize a string is by using double quotes. So let's say I have a variable called first name, and I want to initialize it to John. So I basically do double quotes, and then I type in the word I want. So double quotes represent string. Also in Python, you can also initialize a string by using single quotes. So double and single quotes both work for initialization of strings. Okay, the next one is concatenation of strings. So now let's say I need a program which will let me get the full name of the person, right? So I can easily use these two variables I already have, first name and last name. So I can do first name plus a space plus last name. So what the plus operator does is that it takes the two strings and then it concatenates them. So concatenation means it joins the strings side by side. So this empty space is also considered a string. So it will join these three strings, John, empty space, plus Doe. So when you run this, you will get John Doe as your full name. So full name will store the complete name in it. Okay, the next function is the length of a string. So the length of the string basically gives you the number of characters inside that string. You can simply get it by passing in the variable into a function called length. So here length is a function, and then let's say I want to find the length of the full name John Doe. So I pass in the full name to the function length, then it computes some value, right? And then it stores that value inside the variable called name length. So when I print out name length, it gives me the value 8. So if you count the number of characters inside John Doe, you can see that there's 8 characters, including the space. Okay, so next one is slicing strings. So slicing strings is, it means that let's say you want to have a portion of a string, like you're working with some text data and you want to get a specific portion, which is the important part of the text. So in this case, I want to extract the programming language from this text. How do I do that? So I can actually just get the index of the characters and then I can output that. So I basically slice the characters which contain the word Python. And then I slice that and then I store that into another variable. So if you count, you can see that the character P is at position 16 and the character N is at position 21. So what text, so you can use this bracket function where you put in the text, which is the name of the string you want to extract from, then the positions, the start position, which is 16, and the end position, which is 22. So we're putting 22 instead of 21 because it only counts from 16 to the 21 position. So if you put 23 here, it'll count to the 22nd position. So now if I print out the language, I'll get Python. So you can try playing around with this. So let's say I change 16 to 14 or 13. I'll get 2 Python. So it includes 4 more characters, including the space. So this way you can get a substring from a given string. Okay, the next one is splitting strings. Sometimes you have a sentence, right, and you have to split the string into different words. So the way we do this is we use the split function. So we simply get the string variable and call a function called split. So long string is the string we have, and we do dot split. So it basically splits the string into words, and it splits on a space. So if we output split strings now, we'll get a list of all the words. Right. So that's for strings. Now on to Booleans. Booleans are simply logical values, the true or false values. So for Booleans, we have to compare stuff, right? So let's say we have 2 variables. One is year 1 and one is year 2. So these are 2 integer variables with values 2020 and 2021. So I want to see if year 1 is equal to 2020. So I'll run this code. I'll get false. So what this equals thing does is that it checks if whatever is on the left is the same as whatever is on the right. So it's called the equality operator. So it checks if these 2 variables or these 2 objects are equal. So year 1 has the object 2020, which is an integer, and the right side is a string 2020. That's why you get false. But if you simply put 2020 as the integer 2020, you will get true, because year 1 is an integer. So you have to also note that when you compare strings and integers, you'll always get false because a string is not an integer. So what the equality operator does is that it first compares the type of the objects. So the type of year 1 is an integer, and the type of the right side of the equality operator object is a string. So since an integer is not a string, you'll get false, right? So only if the types match, then you actually look at the value. So now let's say you put 2022. So you also get false because even though the types are the same, the value is different. Okay. So, right. Now we go to collections. Now collections are a way to pack many values together in a single variable. So, so far we've seen single variables. We declare variables one by one. But sometimes you have to declare multiple variables at a time, or you have to get a range of values. So for multiple variables or values, you use something called collections. So they're like a sequence of objects in a sense. So a string is a sequence of characters. So a string is actually a collection. A list is a sequence of objects. And so on. So what is a list? A list is a ordered sequence of objects where each object is identified by an index. So it's a collection of objects, and the objects are stored next to each other. So in this list L1, you see we have 4 objects, right? You have an integer object, which is 1, its string, which is the word 2, and another integer object 3, and another word 4. So each object in a list has an index. So an index is used to identify at what point the object is at. So, this list contains 4 elements, as you can see. So how do we access a particular object? We use the index of that object to access it. So in most programming languages, the index is lists are 0 index, which means that the first element has an index of 0, second element has an index of 1, and the nth element has an index of n minus 1. So we always start from 0 when we talk about the index numbers. So what the code here does is, how to initialize a list is we just put square brackets, right? And then we just pass in whatever values we want to initialize it with. So L1 is 1, 2, 3, 4. So basically, this is a list containing 4 objects. So now if you want to access a particular object inside the list, you pass in the index to that object. So L1 of 3 will give you 4 because in this list, the third index is pointing to has the value 4. Okay, so in lists we have a lot of operations. So what we can do is we can the first one is declaration of a list. Second one is we can actually change the value of a particular index in a list. So I have this list which has all these values, right? Now I want to change the word 4 to the Boolean object false. So how do I do that? I simply do list of 3, which is the index at which 4 is at, and then I assign the value false to it. So it changes the value of 4 to the value of false. The next one is I can actually get a subset of a list, right? So let's say I want to get another list which contains a subset of the elements in the current list. So I can pass in the index numbers of the list I want. So a list of 1 to 5, 1:5. So it basically gives me all the elements from index 1 till index 4. So the right side is 5, right? But even though it's 5, we actually Python only returns until the 4th element. So yeah, it gives you a subset of the bigger list. So a list has a lot of other functions where common functions. I'll go through a few of them. It's called append, where you can add an element to the end of a list. Count, which gives you the number of times a particular element occurred in the list. And remove, which removes a particular element from the list, and so on. So you can refer to this on your own time. Okay, so we also look at operators, but before that, let's go back to the collab file, and I'll show you a bit more about lists. So again, this is an ordered collection of objects, and how we declare a list is we use square brackets, followed by inside the square brackets you provide the values you want to put in that list, which are separated by commas. So I declared 2 lists here. One is called nums with the values 1 to 7, and the other one is days with the first 5 days of the week. Right. So now let's say I want to access the first day of the week, the Monday. How do I get Monday? So I can simply, since the list starts from 0 indexing, Monday will have, and Monday is the first element, it'll have an index of 0. So I simply do call days and then open bracket, square brackets, and then I pass in the index I want, the index of the element I want to get back. So since Monday has index 0, I pass in 0. Then, so this will basically access Monday and return Monday to me, which I will store in a variable called first day. So when I print first day, I'll get Monday. Similarly, let's say I want to get the length of a list. You can again use the length function where you pass in the object whose length you want, and you will get the length of days, which is 5. So now let's say I want to add another day to the list, right? I want to add Saturday to the list. How do I do that? So we can use the append function. So the append function basically takes in an object which you want to append to the end of the list. Append means add to the end. So since the list name is days, I will do days.append, then open brackets, then I'll pass in the object I want to append. So when I do this, and I output days, I get 7. So basically it appended Saturday twice to the end of the list. So every time you call append, it'll keep adding to the list, right? So if I run this code again, it'll give me another Saturday at the end of the list. So yeah. Okay, now tuples. So one thing about lists is that it's mutable, which means that I'm able to once I declare a list, I can change the elements inside it. I can append to the list, I can delete from the list. I can change the value of a specific object inside the list. But tuples are not like that. When I declare a tuple, instead of using square brackets, I use curly round brackets. So the thing about tuples is it's the exact same thing as a list, except that it can't be modified, which means it's immutable. So if I try to remove an object or if I try to add an object to a tuple, it doesn't work because you can't change the elements or modify the elements in a tuple. So, okay, if I try running this code, right, if I try to change the first element of the tuple to 3 by doing num0 equals 3, I'll get an error. This is because I'm not allowed to change a tuple in Python, right? And the last variable we want to deal with is dictionaries. So a dictionary is a collection of key value pairs. So it's also a collection in the sense that you can store multiple objects inside it. And it actually consists of key value pairs. So what are key value pairs? A key value pair is basically something like an index, right? So for arrays, you have integer indices. So the indices are from 0 to n-1 if the array has n elements. But sometimes you require different type of indices. Like you have to have a string as an index. So if you want indexes which are not restricted to numbers or integers, then you use something called dictionaries. So in dictionaries, we have key value pairs. A key is how you identify something in a dictionary, and a value is something something associated with that key. So let's say I want to store the grades of a person in semester, doing some modules in semester 1. So, and let's say the person got GPA 4 for 1010, CS 1010, GPA 4.5 for CS 1231, GPA 5 for MA 101, and GPA 3.5 for JAR 1000. So I could store these in an array with the values 4, 4.5, 5, and 3.5. But what's the problem? The problem here is that I don't know which module it's associated with, right? Maybe I can, if I can probably keep track of like, okay, CS10 is the first element of the array, 1, 2, 3, 1 is the second element, but it's confusing. Also, like, you know, if you forget the order, then you can never like find which module each grade belongs to. So a dictionary solves that problem. It basically allows you to associate a value with a key. So now if I want, I can store the value 4 for the module CS1010. So I can basically access these values by calling the key. So grades is a dictionary name, and then I pass in the name of the key inside the square brackets. So what this does is it outputs the value associated with that key. So the key 1010 has the value 4. So when I do grades and then open bracket and then I pass in that key CS1010, I'll get the value associated with it. Same thing for CS1231. I get 4.5 back. So in this way, I can easily keep track of what grade that person got for each module. And one thing to note here is that keys in a dictionary should be unique. So you can't have like two keys with the same key value. So another thing you can do for dictionaries is you can create a new key and then assign a new value to it. So let's say I'm doing 2040 and I got 4.5 for that. So I can do creates 2040 equals 4.5. So this basically creates a key if it doesn't exist, and then it assigns the value 4.5 to that key. And I can also modify a particular key in the dictionary. So let's say I got 3.5 for JAR, right? And I didn't like my grade. Then I felt like SUing it. So I would change JAR 1000's value from 3.5 to S. So now when I output my new dictionary, you can see that there's one new element, CS2040 added with the value 4.5, and JAR 1000 changed from 3.5 to S. Right. So iterating through a dictionary. We'll cover this later, but so with all the elements in dictionary, sometimes you want to print out everything or access everything in one go. You don't want to keep on calling grades and then followed by each key and then value, because it's too time consuming, right? So you can if you want to print out everything in a key, you can use something called a for loop. So I'll just leave this here, but we'll cover for loops later. We'll get back to this part later. Okay, so we're pretty much done with variables. Next part is operators. So operators basically used to combine objects and evaluate form expressions so that we can easily evaluate expressions and get a result. So let's say I have two objects, two numbers, and I want to get the sum of those numbers. So I use an operator, and then I can simply create an expression and evaluate that using operators. So the common operators like in Python, like in maths, are the addition, subtraction, multiplication, division. And then there's also some special operators called integer division, which basically returns you the quotient when you divide I by j. And then there's this thing called the modulus operator, which returns you the remainder when you divide I by j. And then star star refers to power. So if I want to do I power j, I do I star star j. Then the next one is plus equals. So it's actually a shortcut for x equals x plus y. Okay, so you can see some examples of the operators in use. One thing to note here is that if you put brackets, then whatever's in the bracket will be evaluated first before moving on. So you can see that this 2 plus 3 into 5 here, we get 17 because multiplication has precedence over addition. But when you put brackets, you will evaluate whatever's in the bracket first before multiplying. Okay, so those are arithmetic operators now we have another type of operators called comparison operators. So comparison operators basically compare objects and return a true or false value. So the common comparison operators are the equal to operators, which we saw. Basically, equal to operators returns true if both of the objects are equal. So x equals y. And then there's the opposite of the other not equal to operator. So if x is not equal to y, you get true. Then there's the greater than, less than equal to, greater than equal to. So some examples here, if 10 equals 11. So since 10 is not equal to 11, you get false. And then 10 greater than or equal to 11, 10 greater than or equal to 10, it's true. So it's very logical in the sense that it's a simple comparison and it's not that difficult to understand. The next part is something called and, or, and not. So these are also comparison operators. So basically, what an AND operator does is that it takes two Boolean values, and then it gives you it basically ANDs both of those values and gives you an output. So how AND works is that if both A and B are true, it returns true. But if either A or B are false, then you get false. Same for OR, it's the opposite. So if A or B is true, if any of these expressions is true, then you get true. But if both are false, you get false. And for not basically inverts the truth value of a expression. So if I have a false value and I say not or false, I'll get true. Okay, so now we'll go into operators and see some code. So you can look through all the common operators in Python here. And you can try running this code on your Colab notebook. So, okay, a very useful operator is actually the percentage operator, which is not that commonly seen in maths. So if you're new to programming in general, then it'll be quite new to you. So percentage basically returns the remainder when something is divided by something. So in this case, the left side, which is 10, is divided by 7. And then the remainder when you divide is 3. So the percentage or modulus operator returns the remainder. Now comparison operators. So we can see A is 10, B is 15. And if you do A equals B, we'll get false as expected because A is not equal to B. Sorry, A is not equal to B. And if you do A not equal to B, you get true. So now we move on to the AND operator. What does the AND operator do? It basically takes two expressions on either side of it and then returns true if both of the statements are true and false otherwise. So if A is greater than 3, and b is greater than 20, then I'll get true here. So since a is 10 and b is 20, both of these expressions are true, right? So I'll get a 20. So I'll get true. But let's say I do a is greater than 11. So since the left side is false now, the whole operation will value to false, because if you have even one false inside an and, you will get false. But if I change this and to a or, I'll get true back. Why? Because the or operator basically looks for one true value. If any of the value is true, either value is true, you get true back. Only if both values are false, you get false. Okay. So now we'll talk about conditional statements. So a conditional statement is something you use in Python to change the flow of control. So far we've seen code which executes in order, right? Like every single line of code is executed all the time. But sometimes we don't require every single line of code to be executed. We only require certain specific lines to be executed. So let's take an example of, let's say we have a number 20, right? So, and okay, so let's say we have any number and we want to print 20. We want to print the number is 20 if the number is equal to 20. But if the number is greater, we want to print greater than 20. And if the number is less than 20, we want to print less than 20. So for whatever number we have, we will never have to print all three of these statements. We only have to print either one of these three statements. So when we want to print based on some condition, then we use something called a conditional statement. So in Python, the main conditional statement is the if statement. So if statement is something which takes in a condition or an expression, and then if that expression evaluates to true, it runs the code underneath it. So yeah, so an if statement has this syntax, right? So if, and then you open brackets, and then you pass in a condition or an expression. So if num equals 20. So if the number is 20, then you print 20, and then otherwise you go down to the else part. So basically, if this condition evaluates to true, then you will print 20 and then you'll end that control. So the program will start executing from the bottom, like of the else part. So yeah, so this is what happens. So if the number is 20, then you'll print 20. But if the number is less than 20, then you will print less than 20. So basically, if the if part is true and you execute the print statement, then you would skip to code after. But if the if part is false, then you will go to else if. And now if the else if is true, you would again print number is greater than 20, and you would skip the else statement to the code after. So yeah, at one point only one of these three lines will get run. Okay, so let's go back to the collab file and execute the conditional statements. So we have two variables here, x equals 10 and y equals 90. So we want to print condition is true if x is greater than 20 or y is greater than 100. So if we try this out, it'll print true. Why? Because the if statement takes in this expression, x greater than 20 or y greater than 100. And since x is greater than 20 and y is greater than 100, so this expression evaluates to true. And since the statement is true, we will print out whatever code is underneath it. So one thing to mention here is that whatever's under the if statement is only what's executed. So let's say I have, okay, so when whatever's under the if statement is called the body of the if statement, and the body basically starts from 4 spaces indented to the right. So whenever you declare a body of any if statement, then you have to actually leave 4 spaces from the start. So only then will Python interpret it as the body of the statement, right? But if I don't do that 4 spaces, then it won't be considered as part of the if statement. So see, currently it will print out true and high, but let's say I make this condition false, right? So I say x is greater than 20, okay, and y is less than 90. So the if statement will be false now. That means the print true won't execute, but the high will still be printed out because the high is not inside the if body. Okay, so the example in the PowerPoint is here. So since the number is 20, you print out number is 20, but if it's less or higher, print out the appropriate statement. Okay, so let's move on to loops now. So loops is one of the most important concepts in introduction to programming because it allows you to take a repetitive task and make it easily accomplished. So if you have some task which is like very repetitive, you can usually use loops to make your life easier because loops help you do the same thing multiple times or repeat things. So in Python, there are two types of loops. There's the for loops and the while loops. So a for loop iterates over a sequence, and a while loop will test a condition and keep on running code. So we'll see each by turn. So firstly, we have for loops. So what a for loop does is that it iterates over a sequence. So colors equals red, green, blue is an array here, right? An array is a sequence of objects. So now we want to print out all the elements of the array. So what do? We can iterate through the array. Iterate means you go through each of the elements inside that array one by one. So the syntax here is for color and colors. So this colors is the name of the sequence or the array we have. Now color is the variable which stores the current element. So when we iterate through the array, we iterate through each element one by one, right? So this color variable will store that each element value. So for each iteration, which means each run of the loop, color will have a different value. So for the first run, it will be red, second run will be green, and so on. So initially we start the for loop, we go into the body, right? Now we print I love and color. So since the value of color is red, we print I love red. Next one, we go into green. And since the value of color now is changed to green, we will print I love green. Again, we iterate through. Color will take the next value in the array, which is blue, and it'll print I love blue. So in this way, it will sequentially iterate through the array, and we can update the value of the variable color, and we can use that variable inside our loop body to print out whatever we want or do our function, do our computation. So you can again see that there's a loop body here, right? There's a indentation of 4 spaces between the start and the start of the print statement and the start of the line. So this indentation shows that it's part of the for statement body. Okay, so now we have while loops. So a while loop basically tests a condition, and then based on that, it enters the loop body. So if the condition is true, it will execute the loop body, and then it will again check if the condition is true, and then it will keep on executing. So let's say we have a while loop like this: while I less than 3, I plus equals 1. So firstly, we have the condition I less than 3. So initially the value of I is 0, right? Yeah. So initially the value of I is 0, and we enter the loop. So now we are at this statement while I less than 3. Now we go back to the top and check the condition again. Now 1 is less than 3. So we again go into the body and it increases the value. Now I becomes 2 if the condition is still true. So we again go into the loop body and iterate the value. So now I becomes 3. And at this point, I becomes less, the condition is validated to false because I is not less than 3, I is equal to 3. Since it's false, we exit the loop and we execute whatever code is after that. So we'll go on to the code after. So in this way, the while loop checks for a condition and then it keeps on executing the loop body until the condition is met. Okay. So one thing to note about while loops is that you have to make sure that there is some iteration. So meaning like you will update the value of I here is being updated, right? But let's say I didn't update the value of I. So since if I didn't change the value of I, then this loop will continue running forever because every time you go to the top of the loop and then you check for the condition I less than 3, it will always be true. So it will keep on running forever and it will cause an infinite loop. So which will crash your program. So always remember that in while loops, there's a chance of infinite loops occurring. So remember to update your values and make sure that the loop will always exit. Okay, now let's try some, look at some code for loops. Okay, so the syntax for loop again is for a variable and in iterable. So there's actually two syntaxes we'll cover here. So let's say the first exercise is I want to print numbers from 1 to 20. Okay, so I can do something called for I in range. For I in range. So what range does is it gives me something like a list or a list of integers. So if I want all the numbers from 1 to 20, then I would do I in range 1, and then the second parameter is 21, the third parameter is 1. So what this does is it gives me a list of numbers from 1 till 20 with a difference of 1. So if you execute this, it gives me all the numbers from 1 to 20. So to illustrate more, as the first parameter here will give you the first element of that list, right? So if I want to start from 5, I don't want numbers from 1 to 4. I just want to start from 5. I can change this to 5. And if I want numbers till, let's say, 25, I'll put 26 here because it's always, you should always put one more than the number you want because it'll only go till the n minus 1th number. And then lastly, you have this, the third parameter here, which takes in like the counter. So this one evaluates what's the difference between consecutive numbers. So if I want a difference of 2 between each of the numbers I output, I can put 2 here. So that gives me 5, 7, 9 onwards. So this one, the last parameter basically gives you what's the difference between consecutive numbers. So if you, by default, you can just put 5 and 26. So by default, the counter is 1. So it gives you numbers which differ by 1. But if you want to change that, you can put whatever counter you like. And again, if you put just one number in the range, let's say 5, it prints numbers from 0 to 4. So the default is the range starts from 0 and then it goes till 4 and then has a counter of 1. So this is how you print numbers in a for loop. Then you have list iteration. So let's say I have a list here, colors like we saw. So I can easily print out all the elements in the colors list by iterating through the list. So for color and colors, print color will give me all the colors in the list. So as mentioned in the slides earlier, color will store the value of each element in the list for one by one, and for each iteration of the loop, it'll print out that value. So each value of the index of the list. So there are actually 2 more ways to iterate through a list. The next one is using something called range. So again, we can use the length of colors. So the colors array has a length of 4, right? And so it has indices from 0 to 3. Now I can use these indices to print out the elements. So if I do for index in range length of colors, so length of colors will give me 4, and then the index variable will take values from 0 to 3. So when I print out colors of index, I get the same output because index will take values from 0 to 3. So at each point, you can see the index variable's value, and you can see the element associated with it. And finally, the last one is something called enumerate. This is another method of iterating through lists. So you pass in enumerate to you pass in the list name to the enumerate function, and you can print out the index and the element of that list. Okay, next one is dictionary iteration. So we can also use for loops for dictionary iteration, right? In the same sense that we have multiple key value pairs, and it's always not easy to like go one by one and print out each key value pair. So the way we do this is we do for k comma v in ages.items, and then you print k comma v. So basically ages.items will give you a list of key value pairs. So each element in the list is a key value pair, and then the key is stored in k and v is stored in value. So just think of this as you are going through each item in this dictionary, and then for each item, the k will store the key and v will store the value. So when you print out k and v, you will get each element in the list. Okay, next one is nested for loops. So this is where for loops gets interesting. So far we have seen for loops which contain simple statements in the body, but sometimes you can actually take it one step further, and you can put a for loop inside the body of another for loop. So this is called a nested for loop, and it's quite common in two-dimensional arrays. So two-dimensional arrays are two-dimensional lists are lists which contain lists, right? So if I have something like 1, 2, 3, this is a simple list, right? Now, if I have another list, if I want a list of lists, I basically put this inside another list. So I have a bigger list which contains 2 lists as its elements. So this is called a multi-dimensional array because each element in the outer list itself is a list. So yeah, nested for loops are used to iterate through two-dimensional arrays. So we can see example here. For I in range 3, the body contains for j in range 5. So the first for loop is called the outer for loop, and the second for loop is called the inner for loop. So firstly, I will take values from 0 to 2 because range will give you values from 0 to 2. And j will take values from 0 to 5. So for each iteration of I, j will run 5 times. So when I is 0, j will take values from 0 till 4. And then it'll print out this statement. Then I will update to 1, and then j will run again 5 times, and so on. So totally, it'll print out 15 statements. So 5 times 3, 15 statements will be printed out by this for loop. You can try. So you can try playing around with the numbers and see, let's say if you put it as 10, you get 30 statements. So this makes it even more powerful, right? And you can actually take this one step further, and you can put another for loop inside nest again. You can put another for loop inside this second for loop. So it become a triple level for loop. But yeah, we won't go into that. You can try it out later. So yeah, now we'll look at two-dimensional lists. So as mentioned, a list within a list which contains lists as its elements is a two-dimensional list. And we can use double for loops or nested for loops to iterate through a two-dimensional list. So how do we do this? So basically we do for list so we know that each element in the two-dimensional list is a one-dimensional list, right? So for list 1D in list 2D, so this variable list 1D will basically contain or take the values of each of these elements inside the 2D list, which is a 1D list. And then for each of those 1D lists, we iterate through that 1D list for item in list 1D and print out the item. So look, at this point, let's say we are in the first iteration, right? So firstly, list 1D will take the value will have the value 1, 2, 3, with a list containing 3 numbers 1, 2, 3. And then inside the second for loop, you will iterate through this inner list, and then the item variable will contain the values 1, 2, and 3. So if you execute it, you'll see we first go through the inner list, and then we again iterate through that list and print out the elements. Then we move on to the next list inside the 2D list, and then we print out all the elements inside that 1D list. And then we move on to the next 1D list inside the 2D list, 7, 8, 9, and print out each of those elements. So in this way, we can iterate through a 2D list quite easily. Okay, the next one is while loops. So while loops are used to test a condition and execute code. So I'll just simply print out numbers from 0 to 10 in a while loop. So you can see that it tests here number is equal to 0 and it tests the condition that number should be less than or equal to 10. So as long as this condition is true, it will print out the number and it will increase the value of number by 2. So once the value of number becomes increases beyond 12, it will finish the while loop and it'll exit. Okay, so I hope you don't have, if you have any questions so far, please let me know. Otherwise, we'll be breaking out into breakout rooms and working on our first problem set. So the first problem set contains questions and exercises on all the topics covered so far. So do try it out. Some of the questions are a bit difficult, but if you have any doubts, you can always ask our TAs, or you can ask us on the Padlet file. So Gerald will break you out into rooms now, and yeah, you can join whenever you're ready.
No, you're on mute.
Sorry. Okay, so next topic is functions. So a function basically takes in some input and gives you an output. So it abstracts away the details of what goes on behind the scenes. So the main advantage is that when you declare a function, you don't have to know what's going on, right? You just pass in something and you expect some result from that. So someone who's using a code, we can just use a functions. He doesn't have to know like what goes on behind the scenes. So the implementation doesn't come into play there. Example is like, let's say we have a program which computes the hypotenuse of a triangle. So we have two sides, A and B. So the hypotenuse is a squared, or the square root of a squared plus b squared. But we have to do all these computations like a squared plus b squared and then square root the whole thing. But let's say we write a function called hypotenuse, right, which takes in two parameters, a and b, and then it performs this computation and returns the value of the hypotenuse. So when we call the function now, we can just pass in the two sides, 3 and 4. Then the hypotenuse function basically takes in these inputs and then gives you back the output 5. So what we're doing here is we are basically hiding on what goes on behind the scenes. So in a sense, it makes it much easier to handle code. Right. So every time you call the hypotenuse function, we can just pass in the sides and get the result. So the syntax for functions in Python is over here. So firstly, use the keyword called def. So a def indicates that you're going to declare a function. And then you have the hypotenuse, which is the name of your function. Then you have those parameters that you input. So you can have 0 parameters or 1 parameter or more than 1 parameter. And then this return keyword basically tells you what you're returning from the function. So in this case, it takes in two integers, a and b, which are the sides of a triangle, and returns the hypotenuse. So functions also help you reuse code. So once you declare a function, you can use this hypotenuse function anywhere in the code. So instead of writing the square root of a square plus b square at every point you want to calculate the hypotenuse, you can simply call this hypotenuse function. So it makes it much simpler. And the same thing, so if you want to find some of this, you can actually abstract away more details. So the current hypotenuse function basically returns the square of a, the square of b, and then square roots that. So you can again make these sub-expressions into a function. So you can declare multiple functions which do the smaller task. So what you're doing is you're basically abstracting each task into a function. So the smallest of tasks is done by a function, and then you can combine these functions to create a larger function. So now the code becomes much clearer in the sense that you know exactly what's happening, right? Sum of squares will return you the sum of the squares of each of these variables. Square will return you the square of the variable, and so on. So your code readability is greatly enhanced. Okay, the next topic is classes. So classes is taking things to one step further than functions. So since it's like another layer of abstraction, so we can actually create custom objects using classes. Custom objects are like user-defined objects which contain different properties and functions. So for example, we have these objects. Let's say we have a home, a church, and a skyscraper, right? All these objects are actually, they belong to a certain class, a common class called building. So each of these objects is a type of a building, right? It's a specific type of a building. So the common feature among all these three is that they all belong to a building. So this is the concept behind classes. So many objects in Python or custom objects will probably belong to a common class. So we can use a blueprint to create these objects using classes. So now let's say we want to create, so what classes help you do is it improves readability. It helps you organize your properties and functions for a specific object into a common area, and also enables code reusability. So over here, we have a class car, right? So any car you take will have these common properties that they have a model, they have a color, they have a speed. So these are the properties of that class, of that car or a class. And let's say we have a function called accelerate, which basically increases the speed of the car by 5. So all these properties and the functions are declared inside this class called car. So now if you want to create a specific car with like certain specific properties, then you can simply use this blueprint to do so. So this is the syntax. Init is the initialization function. So you pass in the 3 variables, model, color, and speed. So these 3 variables will be the properties of that car, of that specific car instance. So we'll look at how to declare classes now. Okay, firstly, functions. So again, the def keyword is used to declare a function, followed by the name of the function and the parameters it takes. So function can take 0 or more parameters, and it may or may not have a return statement. So if it doesn't have a return statement, then it returns null or none. None is a null value in Python is basically when a value doesn't exist. It's if you're familiar with Java, it's a null. It's similar to a null value. Okay, so we have this function called greet, which takes in 2 parameters, name and time. And depending on the time, we greet the user with a custom greeting. So if the time is in the morning, you say good morning. If the time is in the afternoon, you say good afternoon, and so on. And so the thing about this is that you can pass in a different name and a different time and call the function with that. So depending on the name and the time, the function gives you a different output. So the output is basically customized for the time of the day and the name of the user. So how do you use a function? How do you call a function? You simply use the name of the function, greet, and then you have 2 parameters, right? You have the name and then you have the time. So firstly, you just pass in the name you want to use. So again, Gary. Then you just pass in the time of the day. Say it's 8:34 right now, so 20:34. And then you execute it. So since it's 20:34, it'll go into this body and then check. So if based on the if statements, it will see that it's evening time. So it print good evening followed by the name of the person. So you can see that this function doesn't return any values, right? There's no return statement here. So the return value of the function is null. The print statement is different from the return statement. So you have to understand that the print statement basically just prints out whatever's there on whatever's given to it onto this output console. But the return statement will return a value to you. So we'll see what that means here. So let's say we have a function called your cube, which takes in a number and returns the cube of it. So we can see that there's a return statement here, which returns the cube of the number. So the difference here now is that cube, since it returns a number, you can store that number into another variable. So if you do x equals cube 7, it returns 7 cube, which is 343, and then it stores that in the variable x. Same thing for y, it returns 1000 and stores that in the variable y. So now you can use those variables and you can print out the sum. So if I didn't do return, what would happen? I can just do print instead. So I get an error now. Why? Because x and y don't actually contain any values. It just contains none. It prints out the values, but if I try printing out x now, it contains none because it doesn't return anything. The values you see here are from the print statement, but nothing is returned by the function. Okay, classes. So classes, the syntax is use a class keyword followed by the name of the class. So over here, let's declare a student class, which basically represents the student studying in a university. So the class will have these properties, name, date of birth, university, and course. Now, these properties are the properties of common to that class, meaning like every instance or every student will have all these 4 properties. So when you create an instance of the class, then you will have to pass in these parameters to the class. So yeah, so how do you declare a class? Basically, you use the class name and then you pass in the inputs you need to pass into that class. So you can see what inputs you have to pass in based on this init function, right? So self is a keyword which refers to an instance of that class. But yeah, and you don't have to like know too much about self for now. Just know that whatever comes after self, these are the properties of that class, right? So you would pass in the values for those properties when you declare an instance of that class. So let's say I have a student, John, studying in NUS CS, and with this date of birth. So I would pass in these 4 parameters, and then it will create an instance of student. So and store that in a variable called student1. Same thing for student2. Now I have these 2 variables which are custom objects of the class student. So they're an instance of that class student. So now I can easily access the information of that student using this class or this instance. So now student1 is the instance, right? I can get, let's say I want the name of the student. I can just do student1.name. So since name is a property, it will print out the name of the student. So how this becomes useful is when it abstracts away a lot of the details. So you're storing all these properties under a single variable, under a student class. So now if I want to get the information of a student, I can call this function called getInfo, which prints out the name, date of birth, university, and course. So if you notice here, you have to use this self keyword, which will refer to an instance of that class. So yeah, each instance of that class will have their own properties. So, student one has these properties, right? These 4 properties, which are different from student two. So the self keyword basically refers to that instance, and then, yeah, I'll print out the information of the student. Okay, so this is it about classes. It helps you reuse code. So, now if you want to create another student instance, you can simply do student3 equals something. So you don't have to like individually declare the name, date of birth, university, course, and then assign that to a variable and then keep track of it. You can just pass in all these 4 objects. It automatically assigns it under a common umbrella or a common, which is the class. And then you can have functions associated with it, which will help you like, retrieve that data or modify that data. So this abstraction to keep common things, common properties, and common functions together. That's what a class is used for. Okay, so we can now break out for problem set 2. Okay, let's continue then. So we've pretty much finished with the basics of Python. So now it's the more interesting part. We are going to work with modules and libraries. So a module is a collection of pre-written functions. So it basically helps you, quickly perform computations. Like instead of starting from scratch and coding your own algorithm, you can simply import a module and use the functions that people have already built into those modules. So the way we use modules is with something called an import statement. So we just do import and then the module name, followed by to use a function in a specific module, we just do module.function. So if the module is, let's say, pandas, we would import pandas, and we would do pandas dot and then the function in that, or the function name in that module. So we'll see this later. So modules are what makes Python so great. Okay, so now is the interesting part, introduction to data science. So we'll be seeing some what data science is and what we can use it for, and some applications of data science using some common libraries. So what is data science? Data science is basically applying your programming skills to find patterns or trends in data. So it's kind of like a collection or like commonality between your programming skills, your math skills, and your domain specific knowledge. So when you combine your programming skills with your math skills, and then you apply those skills on a specific domain, then you can find trends and make decisions for certain domains. So let's say we have a e-commerce company. So they would use machine learning, which is a combination of programming and maths. And then they would apply that to their specific domain to see which products customers prefer, or what are the trends in the different shopping patterns or something. So yeah, so applying this knowledge into a specific field and finding trends is what data science is all about. So in data science, the most common libraries or the most basic libraries we use are called, there are three of them: NumPy, Pandas, and Matplotlib. So when we work with data, we have to work with a lot of multi-dimensional arrays, because real world data is quite complex and you require a lot of parameters. So NumPy is a library which helps you easily create multi-dimensional arrays. And we have Matplotlib, which is very useful for making charts, for visualizing data. And finally, Pandas. So Pandas is actually, let's say, one of the most commonly used libraries for data science, because any data manipulation we do for machine learning or for any data like wrangling or data manipulation we do, we have to use Pandas, because we load in data sets and then we use Pandas to open those data sets. So Pandas is actually built on top of NumPy and Matplotlib. So we'll be focusing mostly on Pandas, because whatever functions NumPy and Matplotlib have, they are pretty much already part of Pandas in a sense. So the way Pandas works is with tabular data. So what is tabular data? We have data in the form of columns and rows is called tabular data. So the columns can also be called features, and the rows can also be called observations. So it's something similar to an Excel sheet. So you have your columns with, and each row in a column has data about a specific element. So let's say this is about a specific person, Einstein, who was Swiss and a male, and his category was physics. So how do we create tabular data using lists? We can actually represent a table using lists by, in the sense that each row of a table can be represented as a list. And then the whole table can be represented as a collection of lists. So a table is a two-dimensional list, right? So each row is a one-dimensional list. So we have here a list with three elements: Einstein, male, and 1921. So this row, this list, one-dimensional list, corresponds to this row over here, and similarly so on. So these collections of rows or collections of lists form this whole table. We can also represent this table using a dictionary, which is a bit more intuitive in a sense, because the dictionary will have the column headers also. So the key will refer to the column name, and the value will be the value in that column for a specific row. So this is a list of dictionaries, right? So each element in that list is a dictionary, and each dictionary basically represents one row along with the column name. So you can see here again, the name is Einstein, sex is male, and year is 1921. So that dictionary corresponds to a single row in the table, and multiple dictionaries together will form a complete table. So the way Pandas works is it processes or handles this tabular data using data frames. A data frame is a two-dimensional data structure, which we can store data of different types in columns. So in a sense, whenever you think of data frames, it's best to think of it as a spreadsheet or an Excel sheet. That's the easiest way to visualize it. It's just a two-dimensional structure which looks like which looks like a spreadsheet. So this is how a data frame looks in Python. So you have your column here and you have your row here, and then each row will have its own index. So you have your row indices here, and you also have your column headers here. Okay, so again, it's basically a table with the extra column header and row indices. Okay, so now let's get to the interesting part, which is working with pandas. So firstly, when we work with any library, we have to import it. So the first statement is importing, right? So we are using three modules here: pandas, numpy, and matplotlib. So this statement import pandas as PD so what it does is that it imports the module called pandas, and then as PD basically means that we will refer to this module by using the variable PD. So it's like a short form. Same thing for numpy and matplotlib. So whenever we want to call the module, we can just use PD, NP, or PLT. Now creating a data frame. So there are multiple ways of creating data frames. So we'll be looking at firstly from arrays. So okay, first I'll declare a random array using numpy. So the syntax is np.random.randint and then 100 and size. So what this does is it gives you an array of size 10 rows and 4 columns with random numbers between 1 and 100. So it'll be a 10 into 4 table basically with random numbers between 1 and 100. So we'll initialize the array. So this is the array we have. Now we can easily convert this array into a data frame in pandas using the pandas.dataframe function. So the standard way of declaring data frame is by using the variable called df, right? It's the most commonly used term for data frame, the variable for data frame. It's kind of like a standard accepted variable name across by everyone. So df equals pd.dataframe, and then you pass in the array you want to convert to a data frame. And then you just output the data frame to see how it looks like. So you can see here, we've made a data frame. We've converted this exact table into a data frame. So it has these columns and these rows. So since we didn't provide any column names, it will default to 0, 1, 2, 3. Starting from 0, it will be a continuous range of numbers. And the row indices will be 0 to the number of rows and 0 to 9. So since we have 10 rows and the indexing starts from 0, the row indexes will start from 0 and end at 9. And the columns will be 0, 1, 2, 3. So we can also use dictionaries to create data frames. So first I'll make the dictionary and I'll show you how it looks like. So this is a dictionary with two key value pairs. First one is a language key, and the value is an array of programming languages. Second one is the difficulty, and it's an array of the difficulty level of languages. So if you convert this into a data frame, you can see how it looks. So basically it takes the first key, which is language, and then all the values under it will go into the column there. Second key will take it, and all the values under that will go into that column. Okay, so this is what is done with dictionaries and arrays, but in real world, we won't use dictionaries or arrays, right? We will actually work with proper data sets from, let's say, a SQL table or an Excel sheet. We'll have to import an Excel sheet, open it in Panda using Pandas, and then work from there. So for this workshop, we'll be using this data set, which I use for the project. It's an interesting data set. So you just run this command. You'll download the data set from GitHub, and it will actually store it in your collab folder. So your collab folder basically contains files which you can upload. So if you want to work with your own data sets, you can actually upload whatever files you want. And then these files will only be uploaded, will only last in this memory when you work with the data. Meaning, like, if you close this tab and you come back after a while, you probably won't find it here. So only while you're actually using this collab notebook and it's running, only then will be stored. So the data is not persistent, meaning it won't be saved across sessions. Anyway, so I'll show you again. If I delete this file, what this command does is, you don't have to know what this means. It basically just downloads the data set from GitHub and stores it here. So if I refresh now, I'll see it's right here. So in the future, when you're working with your own data sets, you can simply upload from your computer using the upload button, and then you can work from there. Okay. So since we have this data set, the title of the Excel sheet is movie seed data, right? So now we have to load this data into Pandas. So what we do is we use Pandas, and then we use a function called read Excel. So now how do you understand like what function to use and what parameters to pass into the function? So you can actually read the documentation. So how do you do that? So you basically click on read Excel, and then you do control space. So control space basically gives you like the documentation, the source code of the library, and like it shows you what parameters to pass in, and you know how the function works and what outputs you get from it. So okay, it may look very daunting at first because it's quite difficult to understand for beginners. But I mean, if you keep practicing, you get used to this format, and it's quite important to learn how to read documentation because a lot of times you have to. The only way to solve problems is to understand how to use libraries properly, and the way to do that is to read documentation and use that. Anyway, so this read Excel function basically takes in the name of the Excel file along with the sheet number you want to open. So here the Excel file, if you download it and check, you can see that the sheet we want is the second sheet. So sheet numbering starts from 0. So if I want to open the second sheet in an Excel sheet, I would pass in 1. If I want to open the first sheet, I would pass in 0. So this command basically opens the Excel file, converts it to a data frame, and stores it in the variable called df. Now, df.head will give you the first 5 rows of that data frame. Okay, so you can see the first 5 rows of the data frame are shown here. Now, the head function can be modified, so you can actually pass in an input, let's say 10. We will show the first 10 values. And so on. So by default, it's 5. And the reason is that, I mean, you get a pretty good idea of what the data set looks like with the first 5 rows. So I'll quickly explain what this data set is. I chose this because it's quite interesting. It actually shows all the movie sessions for the month of Jan 2020 in Shaw theaters across the whole of Singapore. So basically every movie that was run in Shaw is shown here, and each row represents a movie session with its date, day, month, year, which movie is shown, the timing in the hall, along with the number of seats sold and the total seats in that theater or in that hall. Also the order in which the seats were bought and the distribution of seats. So we'll mainly focus on all the columns except by order and distribution. Yeah, but basically this is real life data, which I use for a project. And I chose it because it's more interesting to work with real life data than some common data set which everyone knows about. So yeah. So now when we first work with data, we have to explore the data. We have to see like what each column is like, and get a rough idea of how the data is and what's going on. So we can first print the columns. df.columns gives you all the columns, and df.index gives you the idea of all the indices. So you can see that the columns here, you see all the column names here. And you can also see the start and end index and the step size, which means that there are 11,351 rows, right? Yeah, so it starts at 0 and ends at 11,350. So there are basically 11,350 rows in this data set. It's a pretty big data set. So df.describe gives you some information about the data set. It gives you some statistics about the data set. So it gives you like the count, the mean, the standard deviation, and so on for all the numerical columns of the data set. So you can see that there are only some columns which are numerical, like day, total seats, sold seats, and percentage, and year. So for all those columns, you will get this statistics for each of those columns. So this will be, you will understand the relevance of this in our future workshops, where we will use pandas for machine learning and so on. Just for now, just know that describe will give you this this compilation of statistics for all the numerical columns. And df.info is another function which will give you the information about each column along with the number of values inside that which are non-null and the data type of it. So this one is actually df.info is let's say the most useful out of all the functions for getting the information, because you get the column name, you get the number of non-null values, and you get what data type the column contains. So date is an object, day is an integer, month, year is an integer, and then total seats and sold seats are floats, they're decimals. And by looking at the non-null count, you can also see how many non-empty values are there in the data set. So we can see there are 11,350 non-nulls here. Sorry. So out of 11,350 entries, in all the first 7 columns, we don't have any null values, which means there's no missing data. But for columns 8 till 12, we can see that there's missing data, right? There's only 11,287 non-null values. So the remaining are null. So we get an idea of like, okay, we have to consider that there are missing values in these columns, and you have to keep that in mind while working with the data. So this gives you a quick overview of the characteristics of the data. So now we'll start accessing the data. So before that, we can also easily get the unique values for a specific column inside the data frame. So firstly, the data frame looks like this, right? You have all your columns and your rows. So if you want to access a specific column, you would use square brackets, and you'd pass in the column name, right? Let's say I want to access the theater column. So I'd pass in the column name. I'll get like this, this series of columns. And from there, I can use this function called .unique. So unique will give me all the unique values of that column. So I can basically get to know which are what unique values there are in the theater column. So this gives me a better idea of what each column contains, and better grasp the data set. So you can simply use a for loop to iterate through each of the columns and print the unique values. So for call in df, basically will iterate through all the columns in the data frame. You'll print the column name followed by the unique values in that column, followed by a line to separate those values. So we just try it out. Okay, so now you can see the date column contains all these unique values. So the date runs from 1 to 31 Jan. The day runs from 1 to 31 again. The month is only Jan. The year is only 2020. Theaters, there are J-Cube, Jewel, Lido, Next, Pi, Leba, Salata, Water, Waypoint. Then for halls. So again, there are so many halls, right? But it shows you all the unique halls across the different theaters. And then you can also see the different movies that were there, that were being shown in January. Also the time, total seats, and so on. Okay, so that basically these functions basically help you explore the data and get an idea, a basic overview of what's there in the data set and what type of values you're working with, and if there are any null values or not, and the unique values inside the data set. So the next thing we have to do is filter data. So when you work with data sets, we don't require the whole thing. Sometimes you only want to analyze a specific subset or a specific portion of that data set. So what we do is we can easily get, we can easily filter down to smaller portions, let's say a subset of columns and a subset of rows. So this is what df.loc is for. So basically df.loc will take in this range of column row values. So 0 to 10 is the index of the rows, and followed by a list of column names. So it will return you the rows with indices 0 till 10, or 0 till 9 actually, for the columns theater, hall, and movie. So if you run this, you can see 0 till 10. So basically it gives you indices from 0 till 10 inclusive for the listed columns. So yeah, so you can change this to, like, let's say you want to access the middle column, you want to access something like 3000 till 3300 or 3040. So you can easily slice it and you can get the subsection. Okay. So the next one is conditional filtering. So this one, you're just simply slicing based on a known index and known columns. But sometimes you'll want to like slice or filter based on some condition, right? So let's say I want to get only those rows only those movies which were shown on the 13th of the month. So for reference, we have this data frame, right? I want to get all the movies which are shown with day containing 13. So when the date is 13, the day will be 13, right? So I can simply use this this syntax. So you'd pass in df and then square brackets, and then you do df again, square brackets, and then the column name. So df day is the column you want, and then you're checking for equality to 13. So this will return you all the rows for the column day which contain 13. So it took all the rows which have 13 as the day, and then dot head will give you the first 5 rows. So this way you've easily filtered out all the rows with 13 as the day. Now sometimes this equals you can only use for one specific value, but what if I want like multiple values? So I can also use something called the isin function. So instead of just passing in one value, I can check for equality to multiple values in a list. So if I want to filter out days which rows which movies which are shown on 1st, 3rd, and 5th January, I can just pass in df day.isin, then you pass in this list of values. So I'll get the list of all the elements which were shown, all the rows which contain day value as 1, 3, 5, or 7. Okay, so that's with a single condition. Now, sometimes you'll require multiple conditions, right? So you can actually filter based on multiple conditions easily in Pandas. So now let's say I want to find, I'm analyzing the data set and I'm from JCube. I'm an employee in JCube and I want to find out, or I'm an employee of Shaw and I want to find out like which theaters have a percentage sold of 0.8, greater than 0.8, which means which halls have an occupancy rate of 80% or higher, and which belong to the JCube theater. So I can filter the data frame based on these conditions again. So percentage sold is a column here, which has these values, and I want to have a value greater than 0.8. And the second one is I want to make sure the theater is JCube. So I want to find all the rows, all the movies which are shown in JCube and which had a percentage sold of 0.8. So these two conditions can be put inside this syntax. So basically, this is condition 1 inside this bracket, df percentage sold greater than 0.8. Then you can use this AND operator. So when you work with pandas, you should use the ampersand sign and the pipe sign instead of the AND and OR. So basically, it represents AND and OR in pandas. So you can easily like filter based on multiple conditions using these, right? So when I do this, it gives me all the rows which have theater J cube and whose percentage sold is 0.8. So if you just scroll through, you can see that the theater is always J cube and the percentage sold is greater than 0.8. Now, if you notice, right, the index is all screwed up because it's in different order, because when you filter different, like you take rows from different parts of the data set. So these rows may not be in order. So the indexes will become unordered. So you can actually use this function called reset index to reset the index and make it like reset it to 0 to whatever. So now it reorders the index from 0 to 7. So you can see there are only 7 values with 8 rows which have theater J cube and percentage sold greater than 0.8. Next one is working with missing values. So I'll create a rough data frame for reference. So let's say this data frame contains missing values, right? So you have column B with 2 missing values and column A with 2 missing values. So there are 4 rows with missing values. So sometimes when you work with data sets, missing values will skew your data. Like you'll get inaccuracies, or it'll be like it'll just give you the wrong result. So depending on the situation, you may want to remove the missing values, or you may want to change the missing values to a standardized value for, let's say, like 0. So what you can do in pandas is that you can either drop the missing values. So you can drop any row which contains a missing value. So you do that. You pass in the data frame name, which is missing df dot drop na. So we'll drop all the na values, and then you can actually read up on the documentation. So so this is a parameter called how. So if you put how equals any, then if there are any values present, you will drop those rows or columns. And if you put all, then you will drop a column only if every value in that column is a NA value, right? So basically, if you put any, then if there's either any of the columns contain an NA value in that row, it'll drop it. And for all, it'll only drop it if every value is an NA value. So if you run this, you will see that you'll get this new data frame, which contains only one row because all the other rows have at least one NA. Now, another thing you can do is you can actually change those NA values or NAN values to a preset value. So instead of NAN, I can just put 0. If I want to change everything to 0, I can just do fill NA and then value equals whatever. So I can change this value to anything I want. I can just say, I can change it to a string called null. So what it does is just takes any NA value and replaces that in the data frame with the value you pass in. And finally, you have this isNA function, which basically takes in a data frame and then outputs all the columns which contain null values. So if a cell in that table or data frame contains a null value, you will get true. And if it doesn't, you'll get false. So again, this is useful when you're working with manipulating data sets for machine learning purposes, which we will see in future workshops. Okay, the next one is performing operations, right? So now, so far we've seen like filtering data and accessing data, but sometimes you have to like create new columns in the data frame. So again, if you refer to this, you can see that there's all these columns, right? But let's say I want to make a new column. So I want to see which halls which movie sessions are the popular ones. So if a particular session is popular, I would say that like a lot of seats will be sold for that session. So basically, let's keep the cutoff as 80%. So if 80% or higher of that theater is sold for the movie session, then I would classify that as popular. So I can easily like create a new column called popular, and then based on this condition, I can make a true or false value. So basically, I do df popular, which is the popular is the name of the new column I want to create. And then I'll do equals to, and I'll do df percentage sold greater than 0.8. So what this does is we'll create a new column called popular in the data set. And then it'll check the percentage sold column. So if the percentage sold column is greater than 0.8, it will return a true value. And if not, it will return a false value. And then whatever value it returns, it will store that into the corresponding row in the popular column. So if I run this, you can see what happens. Let me output it. Okay. So now, depending on the percentage sold value, it'll have a true or false value in the popular column. So since 0.13 is less than 0.8, it'll return false. But this movie session, 0.88, it was greater than 0.8, right? So it'll return true. And so on. So, you have like, with a single line of code, you have basically created a whole new column, and you have like used a Boolean operator to find out if the percentage sold is greater than or less than 0.8 for every single row in this column. So that's why like pandas is so powerful. You can easily manipulate data and create new columns. Okay, the next example is another column called percentage sold. Sorry, so we can also, instead of creating new columns, we can manipulate currently existing columns. So as you can see here, the percentage sold is not in the correct format, right? It should be like, when you talk about percentage, it should not be 0.13%, it should be 13%. So, okay, there's an error here. We have, it's actually divided by 100. So to rectify it, you have to just multiply it by 100. So you can simply just do that. You can just do df percentage sold equals df percentage sold at 100. So it basically multiplies every single value inside that column percentage sold by 100, and then changes that in the data frame. So now if you output the data frame, you can see that, yeah, it's changed. Okay, so the thing is we ran this twice. So yeah, it's changed now to the correct value. Okay, so next one is sorting. So, when you work with data frames, you also need to sort sometimes, because sorting is a very useful feature. It's used everywhere. Let's say I want to sort by the day, right? In reverse order. So I want to see the 31st on the top. So I can simply sort the data frame by using this sort values function. So df.sort by, when you pass in the column you want to sort based on, and then the order. So it'll sort and based on that column in the given order. So now the 31st will come in the beginning. And you can sort by similarly by other values like sold seed. So it'll show you sold seeds, the highest ones, and so on. Okay, and finally, we have creating a column based on another column. So what this does is, let's say I want to make a column, and then the value of that column should depend on the value in another column, right? So let's say I want to create a column called week, and then I want to classify which week of the month each session belongs to. So if the day is between 1 to 7, I want it to be in week 1. If it's between 7 to 14, it should be week 2, and so on. So what I can do is I can use this df.loc function like we saw before. So, and then I can pass in this conditional statement here. So what this does is it checks if the day of that row is contained in the values between 1 to 7. So range 1 to 8 will give you values from 1 to 7. And then if that is true, if the day value is between 1 to 7, then I would create a column called week, and then with the value week 1. Similarly, if the day is is between values 8 to 15, then I would say week 2. And if and so on, from 1522 is week 3, 22 to 32 is week 4. So if you run this code and you output the data frame, you can see that there's a new column called week, right? So depending on the day of the month, it will show the corresponding week. So 31st is probably supposed to be week 5, but yeah, you get the idea, right? So again, this is how to create a column based on the value of another column. So it's, yeah, again, it's very useful because you can do this like really fast. Now next, okay. So far we've seen like manipulation, creating columns and accessing columns and rows and subsets of that data set. So now we'll be going into a bit of analysis. So when we do analysis using pandas, one of the main things we use is the group by function. So grouping is very commonly used. If you have used Excel, you're probably familiar with the pivot table function. So you aggregate data based on specific columns. So this gives you a very good overview of like what the data contains and what the trends are in the data. So you actually group, you use a function to group based on a column. Like let's say I have all these halls, so I can group by the halls, and then I can find out for each hall what the statistic is for, let's say, the number of total seats sold and the total seats in that hall. And by grouping by each hall, I can sum up like all the total seats over the month, and I can get a better idea of the data. So the group by function is, yeah, helps us to make group stuff and make analysis easier. So in pandas, we use this group by function. So how it works is you pass in the column you want to group by, and then you pass in an aggregation function. So what this does first is it basically groups the data set based on the theater. It takes the theater column and it takes the unique values in that theater column, and then it uses that as the index to group, and then it sums up all the numerical columns. So you can see what happens here. You're actually taking the unique values in the theater column, and you're grouping by those values. So we have the indices as J-cube, Jewel, and so on. And then we use this function called dot sum, right? So basically, it sums up all the numerical columns across these theaters. So it basically sums up all the days for J-cube, all the year values for J-cube, the total seats for J-cube, the sold seats for J-cube, the percentage sold, and so on. So, okay, so you know that when you sum up days and years, it doesn't make sense because there's no point summing it up. But it does make sense to sum up total seats and sold seats. So we can filter out and get only those columns which contain total seats and sold seats. So now we have a group data set, which basically presents the data in a much nicer format. So we can see that there's a total number of seats is 160,000 almost, and the sold seats is this much. So now using this data, we can calculate the percentage sold. And then we can probably get an insight of, you know, what percentage of each theater is being utilized. And based on this, maybe the movie theater can make a decision into improving the service or changing the timings, or try to attract the crowd more. So this is how data analysis works. You group data, you find some trend in it, and you try to analyze it. And yeah, based on that, you make some decision. So now you can calculate the percentage sold column, which is basically the sold seats divided by total seats into 100. And then you can sort by the percentage sold. So you can see that out of all the theaters, Next has the highest percentage sold. Lido has the second most, and so on. So the theaters can, you know, see which is the most popular theater, and they can maybe implement like a crowd control system, or yeah. Again, so we can also analyze the popularity of movies. So for that, we group by, instead of grouping by theaters, we group by movies. So for each movie, we can find total seats and the sold seats. So total seats, yeah. So now you can again probably sort it and check. So dot sort by equals ascending. Oh, sorry. By equals percentage. Actually, no, wait. Yeah, so after this, you can compute the percentage of seats sold. So whenever you do a group by function, you actually have to assign it to a new data frame, right? So let's say DF3, because you have to store that data frame somewhere. Yeah. So now I'm going to calculate the percentage sold for the movies, for each movie. So basically you divide the total seats, divide the sold seats by total seats for each movie, and multiply by 100. And then you output the data frame. You can see the percentage sold. So you can easily see that, you know, some movies had like a really high amount of seats sold and some had less. And yeah, you can get a general overview of the data. Okay, so now so we have all these tables and, you know, pivot, all these group tables and data frame. So having this is good, but when you want to analyze data, it's always good to visualize it. Visualizing helps it, you know, helps you like identify trends way easier, because humans are very visual creatures, and we identify, you know, we can look at a photo or a picture and then identify trends much faster than looking at numbers. That's why we can easily plot stuff using pandas. So how do we plot? We basically use the plot function. So we do df2, which is data frame name, dot plot, and we pass in the type of chart we want to get. So if you again look at the documentation for the plot function, you can see that you can get multiple types of charts. Let's say line, bar, horizontal bar chart, histogram, and so on. So currently the df2 is this data frame that we created of the theaters with the sold seats, total seats, and percentage sold. So if I plot this, you can get an idea. So you can see now visually which theaters had the highest, you know, highest sold seats and total seats. So you can clearly see that Lido had the most total number of seats, and sold seats also Lido had the highest. Now we can also like adjust these plots using matplotlib. So that's why I use PLT. So currently we don't have, like, you can see these X labels, X-axis labels are like, you know, horizontal, like vertical, and doesn't look good. So we can't read it it's quite difficult to read it. So we can actually increase the font size, and we can rotate it towards the left to make it more readable using something called plt.xsticks. So it just changes the X-axis labels, font size, and rotation. Then you can also add a custom label. So if I want to make it like theaters in Shaw, I can create my own custom label. I can also create my own label for the y-axis using plt.ylabel and passing in the string. And then I can also add a title using plt.title, and I can, yeah. So after I do all this, I can call this plt.show function, which basically displays the new graph. Oh, what happened there? Okay, I don't know what happened there. Okay, we'll skip this for now. Okay, so instead of plotting bar charts, we can also plot different types of charts like a horizontal bar chart. So this gives you another idea of, the theaters. So we can first transpose the data. So, currently the DF looks like this, right? Looks like this. Now we can do something called the transpose function to change the, to flip the data frame and flip the indices and the columns. So the indices will become the columns and the columns will become the indices. So it gives you like a different way of looking at data. So instead of grouping by theaters, now it will group by the totals, the seats and the percentage. So now if you plot this, we can get another, we group all the theaters together under the total seats category. So we can actually compare the theaters side by side for each of these parameters. Right, so you can actually try experimenting on your own with different types of charts. So yeah, let's say over here you want to have a line chart. So it'll plot the parameters on a line chart. And there are a lot of different types of charts you can play around with. So just explore the plot function, read the documentation, and you can see. Yeah, that's pretty much it. So now we can break out for the third problem set.
Yeah, so thank you, Noel. Yeah, so unfortunately, due to like time constraints, we won't be doing problem set 3 now. So we'll be ending it here today, but we'll send you guys like the answers for all the problem sets after this. It'll be to your email. Yeah, so before we wrap up, right, actually I have a few things. The first is we want to take a group photo. So all of you guys who are over here, turn on your camera.
Yeah, before I forget, we love your feedback on the workshop. So you can scan this QR code to give your feedback. And of course, if you want to keep on exploring, code every day, explore different libraries, and build your own projects. And if you don't know something, always try Googling it and reading the answers. Learn how to read other people's code. Yeah. So, and follow us on our social media on Telegram, LinkedIn, and Instagram.
Okay, we've taken the photo already. Yeah, so apart from the feedback, right, I have one more advertisement to do for DSC Tech. So we have this two industry talks, one on 22nd and one on 29th of October. So basically we have invited like senior management and like founders of various fintech startups to speak on 22nd and 29th of October. So if you guys are interested, you can visit our website, DSC Tech, to find out more. You can scan the QR code here to find out more as well. Does anyone have any questions or like feedback? You can just unmute yourself. Yeah. Okay, so if there's nothing, then does the tech team have anything to add? Okay. Yeah, so I guess we'll end it for here today. Yeah, thank you guys for turning up, and also to the tech team for turning up and helping out in the breakout rooms. So thank you guys.
Thank you.
Yeah, thank you.
Thanks a lot.
What do you guys think about the breakout rooms thing? Were there a lot of like absent members, like absent participants?
Yeah, most of them were quite quiet. Didn't
Oh,
respond.
okay.
Yeah.
Yeah, it's very difficult to engage them. Yeah, and also
I guess I
because
think
very few people.
yeah, I think like it's like okay, like Friday night to be honest is like a lot of people sign up, but yeah, I guess it's because it's a Friday night. But yeah, I think maybe for the next workshop or the next two workshops we'll focus more on like the practical examples or like because I think there was some feedback on like the first 2 hours is a bit too much like theory.
I mean, yeah, you told us to assume that it's all intro.
I mean I wrote that but yeah, I guess like most of the participants were looking more for more data science content.
Okay.
Which I think that the next two workshops will be like providing. But yeah, if there's nothing else, then you guys have anything else to add or feedback? If there's nothing else, then we'll just wrap it up for here today.
Okay.
Okay. Nothing else, huh? Okay. Yeah. Thank you guys.
Thanks,
Thank you.
guys.
See you.
Yeah, thank you. Bye bye.
Bye.